which is relative velocity. We touched on it very, very briefly in the grade 11 course, and really in the grade 12 course. This would be the main new thing in the grade 12 motion curriculum, and it's so easy on one hand, but I think the terminology in that makes it tough, and it just, you have to just pull yourself back from worrying about the terminology and the proper variable names and that, and think about what makes sense, and you won't have too much trouble with it. A quick thing about relative velocity is we never assume acceleration. We're always talking about a uniform motion situation where there's just the only equation, really, besides vector math, the only motion formula we use is distance equals speed times time. Okay? But when we're talking about relative velocity, it just means that from our point of view, we're saying it could mean a lot of different things. I mean, it could be, the car driving at 10 meters per second on the road being passed by a van moving 12 meters per second, and their relative velocities are 2 meters per second. I mean, that's something. The practical examples we use so often in this course are, we're talking about something moving relative to a medium. And the medium, in the case, I'm talking right here, this first one, you got an object, a boat, and it's moving in the river. And it has its own speed, where if the river was still, it had no current, the boat could travel at. But as soon as the river has its own current, then the resulting velocity of the boat changes, right? The velocity of the boat is going to end up being a sum of its regular speed without any water current, plus where the water current pushes it. And this is the question, these are the questions we're talking about. You could say a person on a train. We have a person, that's the object, and the medium is the train. And again, this is, Ferd walks towards the front of a train. The train's moving 30 meters per second on the ground, relative to the ground. Ferd's walking 3 meters per second. So Ferd's velocity relative to the ground is 33, right? And I think that's pretty instinctive. And these are the types of questions I gave you related to relative velocity in grade 11. And then another one that we use all the time is a plane flying through the air. I sometimes think of this as the planes, trains, and automobiles sort of unit. But there you have a plane, and its medium is air. So a little example is, imagine a little duck traveling upstream, so against the current is upstream. The duck, if there was no current, could go 2 meters per second, but the river velocity is going 1 meter per second. And since he's going upstream, the duck must be going 2 meters per second east. That would be its relative to the water. But then you've got the velocity of the water with respect to the shore, which is the river current speed. Okay, so the terminology, and this is what throws you off, because I'm pretty sure you could look at this right away and say, well, relative to the shore, the duck's got to be going, it's being pushed back 1 meter, though it's moving 2 meters, so its velocity will end up being 1 meter per second in the east direction. So that's going to be the answer. I think you can see that already, but I do want to go through the proper terminology so you get used to it, because the questions, obviously with 2D, they get harder, right? So what I'm saying is the velocity of the duck with respect to the shore, so what it ends up doing is a vector sum of the velocity of the duck with respect to the river, plus what the river's doing, what the water's doing with respect to the shore. So, these variable names throw kids off, but, duck with respect to shore, ds, equals duck with respect to river, that's as if the river wasn't moving at all, plus the river with respect to the shore. And becomes the vector addition we do, and that's what you did, probably in your head before I showed you this awful equation. And I don't show it in the grade 11 course because it's unnecessary. You can do it all in your head. In the grade 12 course, where we do two-dimensional vector relative velocity, you have to use it. You have to get used to using the proper terminology in the vectors, the vector names. So here's my math I'm doing, vectors, and I want to find VDS. Well, my duck with respect to the river is 2 meters per second, and it's east, because remember, it's going upstream. So if there was no current at all, it would be moving 2 meters per second east. However, there is a current of 1 meter per second west. So we'll define east as positive, and so when we do this vector addition, it's going to be positive 2 minus 1, or plus minus 1, however you want to look at it. So the resulting velocity is 1 meter per second east, just like we predicted. Okay, some terminology related to airplanes. Um, there's different ways you could do it. I like this: ground speed equals airspeed plus wind speed. And what this means is where the plane ends up going relative to Earth, sort of the flight path, the plane like the flight has to start in Toronto and end in Vancouver. That's the ground speed in a certain amount of time, right? That would give you the ground speed. Equals airspeed is where the pilot aims, because depending on the wind speed, the pilot can't aim directly. If they're in Toronto, forgetting sort of other navigational issues, but just pretend all we cared about was straight lines here. So when you're in Toronto and you're aiming for Vancouver, you'd like to aim straight at Vancouver and just go right there. But if there's a wind speed, you have to adjust that, right? It could be nice. The wind could be right at your back, right? And then that's not a thing. But if there's a crosswind or a wind in your head or like into your face, you have to adjust your airspeed in order to maintain your schedule, get your ground speed. Okay. And these are the proper variable terms. So ground speed would be VPG, airspeed is VPA, and wind speed is VAG. But I like just thinking about terms of the words. So this is the general, where the pilot ends up. Ground speed equals airspeed plus wind speed. Though most often in the examples, or sort of, forget examples, if you think about what an air pilot has to do, they normally have to figure out their airspeed in order to maintain a schedule. So the flight plan is that it's going to take off at 3 p.m., land at 7 p.m., and it has a certain, say Toronto to Vancouver. Well, it doesn't matter what the wind's doing. This is what the pilot adjusts in order to make that schedule, right? The pilot adjusts its airspeed, whether where it points or just how much thrust, how fast it plans on going, in order to attain a schedule. So in a one-dimensional problem, pretending that there's no crosswind, I think you might have to write down this example. I have a feeling I had trouble with the original handout copy, but you can just stop the tape and write it down. But an airplane has an airspeed, and so this one is actually just looking for VPG, but it's saying this airplane, the pilot has set up to travel 450 kilometers per hour, going into a headwind, so that means it must be headed north because the headwind is south. What is the velocity of the plane relative to the ground, and how long will it take to make a certain flight? Okay, so here's the information. We're given airspeed, we're given wind speed. It's just the vector add. If you call north positive, because of the headwind, the plane ends up only going 400 kilometers instead of 450 kilometers per hour north, right? This is another little note, by the way. As I said, we don't use acceleration with relative velocity questions. So normally where I say you have to go into meters per second, in these questions you can leave it as kilometers per hour. Okay. Part B is looking for how long it would take to make a 1,200 kilometer flight with all that, if everything stayed constant. So that would be a simple distance equals speed times time, or time equals distance divided by speed question. 3 hours. Okay, so that's just the start of relative velocity, and I've definitely got more with two-dimensional relative velocity coming up in the next video.